So then it's a scan to BIM and the workflows we have there. So
thank
go
you very
ahead.
much for that, Heidi. Thank you for attending this session, where I'm going to talk a little bit about, as I say, scanning, and in particular some of the tools that we have done in terms of interfacing scan data into modeling software. Modeling software I'm going to look at particularly for this one is SketchUp, but you can use, of course, a lot of other things too. Just as a quick introduction to myself, my name is Tor Erik Djupos, or Ted, as most people call me. I am originally Norwegian, but I've been living in the UK for about 30 years now, so my speaking Norwegian starts to get a bit dodgy. My background is in kind of geomatics engineering. I've been with various type of work in terms of marine, land, and geodetic surveying, and I've been involved with various side of the construction industry since the early 90s. And currently, I work as a senior application engineer within the Trimble geospatial division. Little bit of what we're going to go through, bit of an introduction, and then a high-level overview of some of the workflows that's related to what we're doing. Talk a little bit about scanners, what they are and what's changed and how we work with them. And then we're looking at how we interface this into the modeling and the collaboration side. And we're finishing off with kind of the closing the loop and looking at how you can take this model out in the augmented reality side of things. Not going to dwell too much on the Trimble side, but of course we kind of consist of three main divisions, which is the transportation, eco, and field system. And I think most of what's being presented here today probably comes from the eco side. I represent the field systems. And us in field systems, we are the part of Trimble that are creating a lot of the hardware we're doing. So our precision GNSS, total stations, the laser scanners, these type of things. So a lot of the sensors that we supply and is being used to collect a lot of the data with the corresponding software. You've probably also seen this one. A very important part of what we're doing is, of course, is to have that capability to go from the kind of the physical and to the digital and back again. As you taking our sensors, you're going out and you're capturing what is, and you're feeding that back into the design side of things, and you're creating your design in a digital environment, and kind of you're feeding back in again and doing the building. And of course, a very important part of all this for everybody in Trimble is the Connect. Trimble Connect is the place where all of us is kind of feeding our data into, and so does we in the field system. And the hardware side is the place we kind of deliver a lot of the sensor data that we're giving in. More specifically, for what we're going to look at in the next few minutes, it's scan to model. Now, scan to model can mean many things and a lot, but we'll look at some of the specific things that we've done with some of our products in order to help facilitate and to make that process a bit easier as we go forward. Kind of high level overview first of what how this is. You start with the data capture bit or the scanning side of things, where you go out and you capture what actually is there. The second step in this is the data processing, and I'll speak a little bit about that because this is an area that has changed and is changing quite a lot. Previously, that was pretty much something you did in the office, and to many a bit of a difficult task. But that's kind of changing. Some of these you can pretty much do directly in the field, but depending on the size of the project, you will also take them further on. And then into the third stage, which is the modeling side. In this presentation, we would look a little bit on the SketchUp element of it, but this can be many other things too. If it's kind of steel type of things, you could use the Tekla structure. The same flow will go if you're into Revit, of course. Much of the same thing goes in there. So depending on the model software you're using and the type of models you're creating, It's about taking the scan data in and modeling on top of this. The next step will be then the data sharing or the collaboration side of it. So you created your models, you have your point clouds, and for this we will use Trimble Connect and the associated services that we have inside there to view them. And the last bit in this kind of journey will then be the final end. Either the model goes out for being built, or you can take the model out for the visualization. So what you've scanned, created, you take it with you out in the real world, and you can see how that sits in this specific site. To start with the first bit, which is the scanning side of things, and I don't mean this to be like a Trimble sales pitch in any way, shape, or form, but the scanners is these instruments that you're using to go out there to capture it. One example of that is the Trimble X9. So this is our second generation laser scanners. The first one was the X7, so this is the second iteration of that particular scanner. And today you get it basically in two versions. It's the core and the premium. And the differentiation between core and premium, basically the core is kind of half of what premium is. Core gives you 80 meter distance. Premium gives 160 meter difference. Core scans at something like 500,000 points a second. The other one scans at 1 million points per second. So depends a little bit on what you want to do and need for it. Indoor, maybe core is enough. Going outdoor, when you might need a little bit more distance, you can do these type of things. So why using these type of thing? As I say, scanning has been going through and is going through a bit of a revolution in terms of how to use it. One of the core things when we created this hardware was how can we overcome this specifically the challenges of registrations, making that easy to use for a user, because that was always the biggest part of it. Go out and scan and then put these scans together in a way that it's easy to use. So we've tried to make them as easy as possible to use. So we have things like self-leveling, so the scanners will level itself down to about 3 arc seconds, so you don't have to really think about doing any of that. It will calibrate itself, so you don't really need to send it in for any calibration job, because before each scan, it will calibrate itself. And it's pretty much a one-button operation. So you go out and you scan, and then it's doing it, and then it's the in-field registration that makes it easier. This particular scanner also has a laser pointer, where you can actually use to measure point. Wouldn't call it an EDM, but you can do precision point. The bit that is new with these type of scanners compared to the old scanners are that they now have a data collector. And with a data collector, it gives the operator a much better capability to see what goes on while they scan. It's not just a process that goes on and you will see the result when you come back into the office. You can actually control what you're scanning and see what you're scanning much more in the field as you're there. And you will also get your capability to see that all these scans fits together in the way it should fit. So for example, what you will see as you go along will be a vision like this. So here you've done the first scan and the data can be seen. And as you move to the next point and you start scanning and it's done, the second point or the second station will basically come in. And you can see here that it will align itself correctly to where it needs to be. You will have tools in case of, for example, that registration doesn't work, but you will have tools that can help you to kind of rectify these type of things. But most of the time, if you following a few scanning principles, this registered quite neatly as you go along. And when you're done, you will have your data pretty much there and then. If you have control data, you can georeference the data there and then, so you can pretty much finish the data collection part of this in one go, and you can, before you leave that site, you have a good overview of everything that you needed to do. The next part in this step will be the office processing. As I said, With the previous one, you can actually export your data directly from that tablet and send it to where it needs to go. Depending on the size of the project, you might want to take that into an office software. And if it's purely scanning you're working on, Trimble RealWorks is kind of our premier scanning software. We have others that can also deal with point clouds, such as TBC or Trimble Business Center. But if it's purely scanning you're working with, Trimble RealWorks is what we would recommend. It has all the kind of bells and whistles for doing kind of that interface and manipulating the scan data. You can also do further adjustment and further registration of it. So it's a kind of more powerful way of dealing with that side of it. Of course, RealWorks also, if you have really big data sets, so high density and large data set, it's needs in order to get this more into chunks and blocks of data that you can work with. One of the things that we have seen a huge improvement over the last, I would say, 1.5 years is the whole classification side. So we've had classification for a long time, whereas you go in and let the software find the various type of things. So typical is vegetation, building, ground, floor, wall, ceiling, and these type of things. But with the introduction of all this AI technology, this has kind of opened up a lot of new possibilities, particularly when it goes to the precision of the classification, so how precisely it does it. But we've also started to build in capabilities in the software to let you as a user train up your own classes. So rather than us creating every single class around, you as a user can train the software so that the software can go and find these things. And we have some examples of where this already is being utilized, specifically in the tunneling side of things, where we can go in and find things like rock bolts and this type of things. RealWorks do have some modeling. I wouldn't say that this is probably the main thing, but particularly if you're into the more industrial side, so pipe work and that type of stuff, then the modeling is really specific towards some of these things and doing a good job on that. And also it has one of those, it's kind of semi-collection, so it has an integration to SketchUp as it is, so you can do some of your modeling in SketchUp, or you can do also some of your modeling in RealWorks. So this works in the sort of way that you're doing your modeling in RealWorks, and then it updates SketchUp directly. But I think the better thing that we've done is to start kind of interfacing with SketchUp directly, and that brings me to kind of the main modeling side of here. One of the extension in SketchUp is something we call Scan Essentials. And this is sitting currently in SketchUp Studio. So what is that? Well, what we have done is that we have taken part of that point cloud control, point cloud visibility function from Trimble RealWorks, and we've built that into SketchUp, so that SketchUp will have the capability to read some of these point clouds and much of that same capability that you will have in one of these point cloud systems in order to better interact with your modeling in itself, but specifically this whole ethos of working with that point cloud. Point clouds can sometimes be tricky to deal with. So one of the tasks that's up to us is to try to, how can we create tools so that whoever is working with that point clouds and in that combination with modeling is easier for them to interact with. And that's what we've done with the Scan Essential bit. We've basically taken some of these scan specific tools from Trimble RealWorks, and we've interfaced them into to SketchUp. So some explanation of the ribbon that's capable there. We have some import and setup specific. We have some buttons that specifically goes on the kind of various visibility side of things. Some selection tools, points and lines for kind of guiding. Clipping is all about kind of segment data to something, and last but not least is the repositioning. So put a point cloud to a particular place that it needs to be. Under the setting itself, you will have capabilities such as point cloud opacity, the point size, the density of it, and the colorization. Some people think that it's always better to work in, for example, true colors. But when you're modeling, grayscale sometimes is better, or looking at the intensity values is better. So you will have all that functionality directly in SketchUp. Now, just because that we have interfaced it from our software and you can read the raw RealWorks project files, doesn't mean that it's limited to a Trimble only. So you have the capability to import kind of standard scan files such as E57, LAS. So this is kind of standardized point clouds. So it's pretty much scanner agnostic in terms of what you want to use and take in there. So you can take data from any scanners in there, and you will still have much of the same functionality that is there. Here is some examples of how a point cloud that comes in there, and how you, for example, can use the various colorization to see it, whether it's real color, whether it's elevation based or grayscale. This is all helping you as a modeler to see the contrast of what you're working to. And there's some other tools too, in terms of basically opacity setting to shade things, in and out, so that it's easier to use them. Visibility, as I said, also really help you as part of that modeling side of things, to get a better understanding of how your current modeling job goes on as part of the interfacing with the point cloud. Selections, doing things like dimensions and things like that going in, so it clicks and it selects the right part of the point cloud as you do it, in terms of doing this ones. And then points and lines, these are typically used for kind of guiding you in the modelings. As I said, if you look at these point clouds, it isn't always that easy to see maybe where you're going to attach a point to, or starting to do it. But these points and lines interaction into the point cloud can help you as guidelines and guide points of getting that 3D feeling of where you need to do it. Clipping, this is basically making clipping boxes in various different ways. So if you have a big point cloud and you just want to have a particular part you want to work with, you can use these clipping boxes to just limit it down to what you need to work with. Last bit here is the repositioning. So SketchUp at the moment doesn't really have a coordinate system such as some of our more geodetic specific software packages. Think that's something that's being looked at. So you have the capability to kind of reposition your point cloud relative to some of the things that you may be working on. SketchUp might not have been the software previously where you're doing things too much on the kind of terrain side of things, but we are starting to get that type of modeling capabilities also into SketchUp, to do terrain, more kind of surface generation and these type of things. And one of the later functions they've got in there is a so-called terrain mesh generation. So it can move more into modeling also into that type of feature and functionality. A few words on kind of modeling with it. Of course, modeling on top of a point cloud, particularly if you're modeling something that is, gives you greater accuracy in representing, particularly if you want to model something that want to represent what really is there, and having that point cloud really helps on that particular bit. It's very easy to do documentation, of course, of this type of things, various type of measurements you can use. A point cloud in itself can be a very visual part, depending on the density and these kind of things, of course. You can use it for checking that something that's actually fitting. So if you have a model of something that you go and scan, whether that is a warehouse or a room or something that's going to go in there that you modeled it, you can put it in and you can quite easily see whether some of these things actually fit to where it needs to be. Modeling itself, of course, is it's a task on its own, and as I said, what we kind of looked at here was a little bit on the SketchUp kind of interface to that. The next part of this journey will then be kind of the data sharing and the collaboration, and I'm sure there are probably quite a few presentations on Trimble Connect, but that is kind of the place we can send the model. Trimble Connect can read these SketchUp models directly, so you can just model them and you can send them directly into to Connect. And here, as many of you probably already know, this can be shared in various ways. I think we saw in the previous presentation they were using Connect for sharing some of these quadri models, and the same principle goes here in terms of how you can do that. You can also take the point clouds directly. So through our, well, I wouldn't say it's new any longer, the TICPS service, the service where you can upload point clouds. You can get these directly in, and you can now also visualize your point clouds and your models directly to that. We just had some major updates to this. So you can now do things like, for example, model to cloud comparisons. You can do kind of floor flatness or elevation checks. There's clipping boxes in there. So we try to expand on a lot of this. So the interoperability to that side of it. And then, of course, you can also connect this directly to Quadri through the Quadri connectors. So if you're scanning something and you're building a module that is to go into your Quadri side of things, when you created that model, you can use the Quadri connector to send your SketchUp model directly in there. And again, you will have the kind of scan to model and into to Quadri database directly as it goes. The last bit of this will then, of course, be the visualization of it. So one thing, of course, you can take these models off to our data collectors for the building side, but you can also take it out to see that this is actually something that is, you've scanned, you looked, and you can take it out. I'm sure most people know what Sight Vision is, which is our kind of augmented reality type solutions where you can take a tablet of different types, attach it to a GNSS antenna, and then you can take your model with you out in to the field, and you can look at that. This is just one example of how a SketchUp model is, and you can then walk around and you can view it. When you walk outside, you can see it in a 2D view. You have all the layer capabilities as is, and you can walk around it. So in this case, it's a building, but I know this is being used a lot in Norway for various types of things, particularly on the civil side of things for viewing and seeing. The latest addition to the Sight Vision side is to utilize the new LiDAR capability that specifically comes in the Apple products. So this basically also gives you the capability to put that onto your Sight Vision device, and you can now also go out and use this type of capability to scan your data. Quality of the point cloud is, of course, not as good as kind of a full-blown scanner, but there is lots of use for applications where that is good enough. And a good thing about this is like it's automatically synchronized up to Connect, and there you can drag it straight into your modeling software as you do. In this case, for example, you can import it right into SketchUp, and you can do the modeling there. That was my presentation for this. A bit of an insight into the scanning side of things. We are working this space in kind of the hardware software side of things is an area that we will hopefully see a lot more from us as we go forward. And the important part of that, of course, is also the interface with all the good and great software we have on the whole side of it. And again, for those of you who have any question to me later on, wants to get in contact with me, you can see my email address there. Feel free to reach out with anything that you may have questions about. Thank you.
Thank you so much, Tor Erik. There are actually some questions. One of them is if there is a report that kind of shows how well the point cloud is aligned with the coordinate system, so kind of the, let's say, the accuracy of the point clouds.
In SketchUp?
Doesn't specify.
Yeah, there are. Yes, we have some reports that can come out on that, depending a little bit on where we do it. As I say, we just included some of that type of work in our TRCPS side of things. That's just a visualization for now, but the next part of that is also to get out a more report on that side of things. If you do it in Trimble Access, yes, then it's you have a direct report that can get out of these things. So, yep.
Good. And there's also a question about E57 files. Are you familiar with that format?
Depending a little bit on what they want to know about it, it's a scanning format. So typically, it's either E57 or one of the LIS format people are using for as an external scan format that's been used. But yeah, depending on what the question are, if they want to know the kind of the structure and things like that, I might need to have some.
Yeah, it's if it's possible to check if it's properly formatted in terms of the file structure and such, if that's possible to control in any of our solutions.
Yeah, I mean, I think the checking it is basically when we read it. If it's not formatted the way it needs to be, we're typically can't kind of read the format itself. I'm not aware of any other particular checks on these formats other than that.